Picture a small stretch of the southern coast of India, in the state of Kerala, on a warm morning in late July of 2001. The monsoon has already come, the rice paddies shine a soft green, and the coconut palms lean gently in the wet air. The clouds gather low, heavy with the season's rain. Everything about the scene looks ordinary, familiar, expected, and then the rain begins to fall. But it is not clear, it is not grey, it is the colour of watery blood. The drops land on white cotton shirts hung out to dry, and the shirts turn pink. The rain pools on stone steps in shallow red puddles. It streaks down the leaves of banana trees like a slow wash of thin paint. In some villages, people stand under the eaves of their houses and look at the sky, then at their hands, then at the sky again. The rain looks like rust, or like the juice of a crushed berry, or like something even older and stranger. And this is not a passing shower. Over the next 2 months, red rain will fall again and again across Kerala, in bursts that come and go without warning. It will fall on some villages while leaving the next village dry. It will stain roofs and clothing, and the shallow bowls left out to collect it. Before we go further, the planet has a new quiet wonder to share every night. If you'd like one waiting for you each evening, subscribe and let it come to you. Samples are collected. Scientists look at the water under microscopes, and what they see does not settle the question. It deepens it. The rain is full of tiny red particles, round and thick-walled, roughly the size of a red blood cell. Some researchers say they look like the spores of a common algae blown into the clouds from lichens on nearby trees, colored red by natural pigments. Others look at the same particles and wonder if they behave a little too strangely for that. The debate goes on for years. Papers are published, papers are answered, and the central question, even now, drifts unfinished in the quiet air above Kerala. But here is the deeper thing to sit with tonight. The red rain of Kerala is not a single event. It is one chapter in a very old book. Red rain has been recorded for more than 2,000 years. Ancient Greek writers spoke of it. Roman scribes noted it in their careful, measured way as an omen or a strange marvel. Medieval chroniclers in Europe wrote of days when the water from the sky ran the color of wine, or of clay, or of something in between. In many of those old accounts, the fear was that blood was falling from heaven. In the modern accounts, the fear is gone, but the puzzle remains. And red rain is only the beginning, because the sky, it seems, has been dropping strange things onto the surface of the earth for as long as people have kept records. Live fish still flopping on dry village roads. Frogs, small and startled, tumbling from clouds into gardens. Sheets of ice the size of dinner plates, falling on cloudless afternoons. Colored snow on distant mountain slopes, tinged pink or gold or faintly green. Yellow powder that dusted whole towns and left everyone whispering. Jellyfish, worms, spiders on silk threads drifting down like a slow grey snow. Meat, in one strange and famous case, falling onto a Kentucky farmyard on a clear March day. Some of these falls have partial explanations. Waterspouts, those slender, spinning cousins of tornadoes that form over lakes and oceans, may lift small animals into the sky and drop them somewhere else. Great winds may carry desert dust across whole continents. Updrafts inside thunderclouds may loft strange cargo higher than we would ever imagine possible. These are honest theories. They explain some cases. They do not explain all of them. For this long, slow evening, we are going to walk gently through the many kinds of strange falls that people have witnessed and written down. from ancient temples to modern weather stations. We will look at the theories, and we will look at the gaps in the theories. We will sit with the parts that still have no answer. There is no rush. There is no urgency. The sky, above every roof and every field, keeps its old habit of surprising us now and then. Tonight, we simply wonder about it, softly, together, while the world outside your window grows quiet, and the rain, wherever it is falling, falls in its usual color. Picture a small town on a quiet afternoon. The sky is soft and grey, or maybe a pale washed blue. People walk home along dusty roads, carrying bags, thinking of nothing in particular. And then, from somewhere above, a fish lands on the ground, then another, then dozens more. Small silver bodies scatter across the street, flopping gently on the warm stones. This is not a fairy tale. It has happened many times, in many places, and it is still happening. The town of Lloro in Honduras claims that a fish fall occurs almost every year, usually in the late spring or early summer. When the heavy rains begin, villagers gather the small creatures in baskets and carry them home. In parts of India, Australia, Sri Lanka, and the American South, people have reported the same strange event. Fish, alive and wriggling, tumbling down as though the clouds had emptied a pond. To understand how odd this is, let us picture the fish themselves. Most are small, only 2 or 3 inches long. They are usually freshwater species, the kind you would find in a shallow pond or a slow river. Some arrive still gasping, others frozen stiff, others already dead. They fall in patches, sometimes covering a field the size of a small backyard, sometimes stretching along a single village street. The area they land on is often narrow, as though a hand in the sky had drawn a line and dropped them along it. The reports go back a very long way. A Greek writer, named Athenaeus, working nearly 2,000 years ago, described a fall of fish that lasted 3 days. Roman scholars wrote of the same kind of event. Medieval European chronicles mention it too, sometimes with wonder, sometimes with fear. Sailors kept quiet notes in their logbooks about strange showers over calm seas. In the 1800s, scientific journals began to collect these accounts more carefully, listing where the fall happened, what species were found, and what the weather had been doing. The pattern that emerges is a soft one, blurred at the edges. Fish falls tend to happen during or just after storms. They tend to happen in warm places, in the tropics or the humid parts of temperate zones. The fish tend to be small and light, but there are exceptions to every one of these gentle rules. Fish have fallen from what witnesses called a clear sky. Larger fish have fallen too, though far less often, and in some cases, the animals have arrived so far from any known body of water that no one can quite explain how they got up there in the first place. The simplest guess is that wind lifted them. A powerful updraft, perhaps a waterspout skimming across a lake, could suck water and its living contents into the sky. The clouds could then carry them for miles, holding them aloft until the air grew still and the fish tumbled down. This is the theory most textbooks offer, and it has real evidence behind it. Waterspouts are strong. They do lift water. They can pull small objects into the swirling column of air at their base. But the theory has soft spots too. Waterspouts usually leave other signs. They stir mud, leaves, weeds, and small stones. A true waterspout dump would be a messy shower of pond debris, not a neat sorting of fish by size and species. Yet many fish falls contain only fish, and often only one kind of fish, arriving mostly undamaged. Some fall many miles inland, far from any waterspout that anyone saw or reported. Some happen when the sky, by all accounts, was calm. So we are left with something that is both familiar and strange. Fish falls are real. They are documented in old texts, in newspapers, in scientific journals, in the memories of ordinary people who happened to be walking home when the sky delivered its odd gift. The falls are not rumor. They are not myth. They are a slow trickle of observations spread across centuries and continents. What remains unresolved is the exact chain of events that lifts a fish from a pond and lays it on a street 2 towns away, sometimes still alive. The waterspout idea covers many cases. Some researchers wonder if strong thunderstorm updrafts without any visible spout could do the same work in a quieter way. Others wonder if there are cases we still have no framework for at all. For tonight, let us simply picture it. A dusty road, a soft afternoon. A small silver fish arriving from above, blinking in the light of a world it never expected to see, and a mystery that has been waiting patiently for a very long time to be understood. Long before anyone thought to write down the strange things that fell from the sky, ice was already dropping from the clouds. Hail is the oldest and most familiar of the frozen falls, and even it began as a puzzle. For centuries, people watched round stones of ice tumble from summer storms and wondered how something so cold could be born in warm weather. The answer took a very long time to piece together, and even now, a few parts of it stay open. The story of hail begins high inside a thunderstorm, in a tall column of rising air called an updraft. Warm air near the ground climbs upward, sometimes at great speed. As it rises, it cools. Tiny drops of water form, and higher still, those drops freeze into small pellets of ice. If the updraft is strong enough, it lifts these pellets back up again and again. Each trip through the cold, wet cloud adds a new layer of ice. When you cut a hailstone in half, you can often see these layers, like the rings of a tree. That much is well understood, yet the story grows stranger when the hailstones grow larger. A pea-sized stone is easy to explain. A stone the size of a grapefruit is harder, and the record holders, hailstones as wide as a small dinner plate, sit at the edge of what our theories can account for. To lift such a heavy stone, the updraft inside the cloud must be furious, moving faster than a highway car. Not every giant hailstorm shows that kind of wind, so the question stays open. How do the biggest stones really form? One idea is that giant hailstones grow by sticking together. Smaller stones might collide inside the cloud, freezing into one lumpy mass. Another idea is that certain storms hide pockets of especially fast air that our instruments miss. A third possibility is that the largest hailstones are made in a very particular kind of storm, called a supercell, where the updraft leans sideways and holds ice aloft for longer than seems possible. Each theory explains part of the picture. None of them explains all of it. Then there are the falls that seem to have no storm at all. Sometimes, from a mostly clear sky, a single enormous chunk of ice comes down. These are called megakryometeors. They can weigh many pounds. They punch holes through car roofs and garden sheds and quiet suburban lawns. And unlike hail, they do not seem to belong to any visible cloud. The first careful studies of these icefalls began only in the last few decades. Researchers were surprised to find that the ice inside them looked a lot like ordinary hail. It had layers. It held tiny bubbles of air. It was made of frozen rainwater, not runoff from an airplane wing, as many people first assumed. And yet, when these chunks fell, the skies above were often calm and blue. One theory suggests that megakryometeors form in the upper atmosphere, in a layer called the tropopause, where the air is very cold and very still. Perhaps some rare mix of moisture, temperature, and slow-moving air allows a stone of ice to grow silently, high above where any cloud can be seen from the ground. When it finally becomes too heavy, it falls. A competing view is that these chunks form in ordinary storms that have drifted far away, and the wind carries the ice a great distance before it lands. Some scientists doubt this could work, because a hailstone traveling many miles sideways would usually melt or shatter. The debate continues quietly in journals and weather stations around the world. What makes the mystery deeper is how rare these falls are, and how hard they are to study. By the time someone finds a mega-cryometeor in their yard, most of it has melted. A puddle is not much use to a scientist. Only the largest specimens, gathered quickly and kept in freezers, have offered any clues, and those clues point in different directions. So the frozen stones that drop without warning join a longer list of things the sky delivers that we cannot fully explain. They are born somewhere between what we know about clouds and what we do not yet know about the layers of air above them. They begin as water, become ice, gather themselves into round or lumpy shapes, and one day, for reasons we cannot always trace, they let go and fall. The listener drifting off tonight can picture that slow growth, a silent stone of ice, rounding itself in the cold quiet, high above the fields, and no one yet agreeing on quite how it came to be. Frogs tumbling onto village rooftops sounds like something from an old story. Yet the reports are real, and they stretch across centuries and continents. In small towns and quiet farmlands, people have looked up during a sudden storm and watched small living frogs drop from the clouds. Some land in puddles, some land on tin roofs with a soft, wet patter. Some hop away, dazed but alive, and once the storm passes, the ground is dotted with tiny green and brown bodies, blinking in the strange new light. To understand how something so odd could happen, it helps to think about what a frog is made of. A frog is mostly water. Its soft body is a small parcel of the same fluid that fills our rivers and oceans. That water, some researchers believe, may have arrived on Earth billions of years ago, riding on icy comets and dust from the early solar system. So when a frog falls from the sky in a very slow and roundabout way, it is water returning to the sky and then falling again. The cycle is ancient. The traveler is small. Frog's bones are built from calcium and phosphorus. These elements were forged inside old stars long before our planet existed. When those stars died, they scattered their guts across the dark, and some of that dust gathered into the rock we now stand on. The little skeleton of a falling frog carries pieces of that old starlight. Its skin holds carbon, the same carbon in every leaf and every log and every breath. Its blood carries iron, born in the furnace of a dying sun. Even the smallest creature is a tiny museum of deep time. Now the question is how such a museum ends up in a cloud. One idea is that strong winds, especially the spinning columns of air called waterspouts, can lift small animals from the surface of a pond or shallow lake. A waterspout is a tornado over water. It draws liquid, mud, weeds, and sometimes creatures upward into the storm. The theory says these frogs get carried a short distance through the clouds, then dropped when the wind weakens. It is a tidy explanation, and it may be true for some cases. Yet, the theory has soft edges. Waterspouts usually carry material only a few miles. They tend to drop things in a mixed jumble: mud, plants, fish, and frogs all together. But some falls are strangely clean, villagers report. Only frogs, all roughly the same size, all one species, with no pond weeds and no mud. That neatness is hard to explain with a chaotic column of wind. Some researchers wonder if there is a sorting effect at work, where the storm somehow separates lighter and heavier objects as they rise and fall. Others suspect the tidiness is in the telling, and that the messier details get forgotten by the time the story reaches a newspaper. There is a competing possibility that involves timing rather than travel. In many warm regions, young frogs emerge from ponds all at once after heavy rain. Thousands of tiny frogs, freshly grown from tadpoles, leave the water together and spread across the land. If a person sees this hopping tide during a storm, it can look as though the sky itself is raining frogs. The frogs in this view were on the ground the whole time. They just chose that moment to move. Which explanation is right may depend on the case. Some falls come with clear reports of frogs landing on rooftops high above the ground, which suggests real airborne travel. Others describe frogs only on the road and in the fields, which fits the mass emergence idea. The truth may be a mix of both, and the boundary between them is not sharp. What remains open is how far a small living thing can travel in the sky and still survive. A frog has thin skin that dries quickly. The upper air is cold and low in oxygen, yet frogs have been found alive after these falls, sitting quietly on stone walls, waiting for the rain to end. If they truly rode the storm, they endured a strange voyage. If they only crawled out of the mud, they still carry the same wonder, a body of water and starlight, built from ancient elements, moving through a very old world. Some scientists collect these fallen frogs when they can, studying their species and their condition. Answers are slow to come. The events are rare, scattered, and often reported after the fact, and so the small frogs on the wet roofs remain a quiet puzzle, sitting between meteorology and folklore, waiting for someone to catch a fall in the act. Sometimes the rain falls in colors the sky was not supposed to hold. Yellow rain in particular has puzzled people for a very long time. Whole villages have woken to find their rooftops dusted in a soft golden powder. Puddles turn the color of pale honey. The air smells faintly sour, or sometimes sweet, or sometimes like nothing at all. And then, as quickly as it came, the yellow fades, washed away by the next ordinary shower. To understand a rain like this, we have to think about the forces that move things through the sky. The air above us is not still. It is a slow, invisible ocean, layered and stirred by heat, pressure, and the pull of the ground far below. Warm air rises, cool air sinks. When the sun heats a field or a forest, the warmed air lifts upward in a great soft column, carrying with it whatever is light enough to travel. Dust, pollen, tiny grains of spores no bigger than a speck of flour. This gentle lifting force is called an updraft. In a strong storm, an updraft can rise for miles, moving faster than a car on a highway. It can carry a raindrop up and down inside a cloud, many times before that drop finally falls. And along the way, it can gather things. Pine pollen, for example, is famous for turning rain yellow in the spring, in parts of the American South, in parts of Europe, in parts of Korea and Japan. Whole seasons arrive coated in this fine golden dust. The pollen is so light that a single breeze can lift a forest's worth of it into the clouds. But pollen is only one possible answer. Some yellow rains have fallen far from any pine forest, in the middle of winter, when no plant is releasing anything at all. In those cases, researchers have looked to other forces. Sulfur, for instance, can tint rain a pale yellow when it comes from volcanic activity far away. A distant eruption can send tiny sulfur particles high into the upper atmosphere, where fast rivers of air carry them across continents. Weeks later, they may drift down inside raindrops in a country that never even felt the eruption. Then there is the strange case of desert dust. The Sahara alone lifts hundreds of millions of tons of pale sand into the sky every year. Much of it drifts westward across the Atlantic. Some of it drifts north into Europe. When this dust meets rain clouds, the droplets grow around the grains, and the rain that falls carries a yellowish or reddish tint. Cars parked overnight in Spain or France sometimes wake up freckled with pale gold. The forces at work here are simple ones, but they operate at a scale that is hard to imagine. A grain of dust the size of a comma can travel 4,000 miles on the back of the wind. Still, not every yellow fall has an easy answer. In the late 1970s, reports came from Southeast Asia of a strange yellow rain that fell on remote villages in the highlands. Some believed it was a natural substance. Some believed it was something else entirely. Scientists collected samples and studied them for years. One theory suggested the yellow specks were the droppings of vast swarms of honeybees, released all at once during their cleansing flights. Another theory pointed to unknown chemical agents. The debate was long, and the evidence stayed incomplete, and different researchers still weigh the question in different ways. What all of these mysteries share is the same set of hidden forces. Heat lifts, wind carries, pressure squeezes clouds until they release, gravity gently pulls everything down again. These forces are quiet and everyday, but when they combine with something unusual on the ground, a blooming forest, a distant volcano, a dust storm across a desert, a swarm of insects, they can paint the sky in colors that seem to belong to another world. There is something soothing in this idea. The forces that lift a pine pollen grain are the same forces that lift a raindrop, the same forces that lift a fish, if the conditions are strange enough. The sky is a slow machine, endlessly stirring, endlessly sorting, endlessly moving small things from one place to another. Most of the time we never notice. Once in a while, the machine leaves its fingerprint on our windows and our rooftops, and we look up and wonder what just passed through the clouds above us. The yellow rain is one of the softer mysteries. It rarely frightens anyone for long, but it reminds us that the air is always carrying something, always shifting, always ready to surprise the ground beneath it with a color we did not expect. Picture a quiet morning in the countryside of southern Argentina. The sun is just beginning to warm the grass. A farmer looks up and sees something drifting down through the still air. Not raindrops, not snow. Threads, long silvery threads, floating and falling by the thousands, catching the light like fine silk, and clinging to those threads or riding them like tiny sailors on tiny ropes, are spiders, small ones, most of them, some no bigger than a grain of rice. They come down out of an empty blue sky, settling on fence posts and shoulders, and the tops of hats. This is one of the strangest skyfalls of all, and to understand it, we need to think for a moment about scale. A single ballooning spider weighs almost nothing, around 2 or 3 milligrams. That is roughly the weight of a poppy seed. If you held one in your palm, you would not feel it. You might not even see it without leaning close. Yet these tiny creatures can climb to the top of a blade of grass, tip their bellies to the sky, and release silk so fine it is measured in fractions of a hair's width. Yea, a single strand of ballooning silk can be less than 1,000th of a millimeter thick, thinner than a human eyelash by a factor of hundreds. The silk catches the air, and the spider lifts off. Now imagine how small a nudge that takes. A person weighs perhaps 30 million times more than one of these spiders. If you were as light for your size as they are, a soft breath would carry you across a room. A gentle summer breeze could send you over a rooftop. This is the scale of the world the ballooning spider lives in. Air, to them, is not the thin, invisible thing we walk through. It is a thick, buoyant sea, and the sea carries them far. Researchers have found ballooning spiders drifting in the air more than 4 kilometers above the ground. That is roughly the cruising height of a small bush plane, higher than most mountains on Earth. Sailors more than 1,000 miles from the nearest coastline have reported spiders landing on the decks and rigging of their ships. Think about that distance. 1,000 miles is the length of France from top to bottom. It is farther than a car can drive on a full tank of fuel, and these poppy seed travelers cross it on nothing but a thread and a current of wind. The numbers grow stranger when you consider how many of them travel at once. In a single mass ballooning event, scientists estimate that a healthy meadow can release tens of thousands of spiders into the air within a few hours. In some regions, whole landscapes are draped the next morning in gossamer, thin sheets of silk laid across the grass like frost. Farmers have described walking through fields where every fence wire, every bramble, every blade of wheat carries a silver coating. When the sun rises, the fields shine. Here is where the mystery of scale meets the mystery of the skyfall itself. For years, one leading idea held that spiders were lifted purely by wind. A breeze catches the silk pulls the spider, and up it goes. But some researchers have wondered whether wind alone can explain the launches, especially on calm days when spiders still take off in great numbers. A newer theory suggests that the tiny electric charges in the atmosphere may play a role. The Earth carries a faint electric field. The silk threads may repel one another, spreading like the bristles of a brush and lifting the spider gently upward. It is a quiet, invisible force. Both ideas remain open. Some experiments support the electric picture. Others point back to fine air currents that we simply cannot see. The truth may involve both, or something we have not yet named. What we do know is this: on any given day, a slice of sky 1 kilometer thick and 1 hectare wide, an area about the size of a soccer field, may contain thousands of drifting spiders you cannot see. They pass overhead in complete silence. They cross oceans. They colonize new islands. They land on volcanic rock only weeks after it has cooled. If you shrank the Earth to the size of a beach ball, the layer of air where ballooning spiders travel would be thinner than a coat of paint. And within that impossibly thin skin of atmosphere, a constant, invisible migration is happening. Living creatures moving through the sky, carried by threads finer than thought. We still do not fully understand how they choose their moment. We still do not know how far a single spider can go. Imagine standing under a wide grey sky just before a summer storm. The clouds hang low and heavy, their bellies bruised with shadow. A soft wind stirs the grass. And then the first drops begin to fall, but they are not clear, they are dark, sooty, the color of weak coffee or old ink, or the slow smoke that curls from a dying fire. Each drop leaves a small brown mark where it lands, blooming outward on the stone of a walkway, on the pale cotton of a shirt, on the upturned petal of a flower. This is black rain, and people have reported it for a very long time. The texture of black rain is strange to see up close. It does not look like normal water, tinted by something dissolved inside. It often looks gritty, as if tiny flecks of char are riding within each droplet. Puddles form with a slick, oily film on top. When the film dries, it leaves behind a dark residue on rooftops and windows, a fine dust that a fingertip can lift and smear in. The aftermath: whole villages have woken to find their laundry stained, their rain barrels murky, their white walls streaked with dark tears running down toward the ground. If you could float above one of these dark showers, the sight would be quieter than you might expect. From above, the cloud itself might look ordinary, soft, rolling, grey-white on top and shadowed below. Nothing about the upper surface would warn you, but as you drifted down through it, the air would carry a faint scent. Sometimes it is the sharp smell of burnt wood, sometimes a musty mineral odor, like wet stone in a cellar, sometimes something oilier, closer to petroleum. The color and the smell together are the first clues that ask a question no one has fully answered. Where does the darkness come from? That is the puzzle at the heart of black rain, and it does not have one single answer. One idea is that the dark color comes from soot and ash lifted high into the atmosphere by fires. When a large wildfire burns for days, it can push tiny particles of carbon far above the treetops, up into the layers where clouds form. Water droplets then gather around these particles, and when the droplets grow heavy enough to fall, they carry the soot with them. Reports of black rain often follow large burns downwind, and this connection seems fairly clear in some cases, but other cases are harder. Some black rains have fallen in places where no known fire was burning nearby. Some have arrived after long journeys across oceans, the dark material apparently riding high winds for thousands of miles. Some contain particles that do not look like ordinary soot at all under a microscope. So a second theory suggests that industrial pollution, lifted from cities far away, can travel great distances and rain down in unexpected places. A third possibility is wind-blown desert dust mingling with cloud water, though this usually produces reddish or yellow tones rather than true black. There is also a stranger version of the story. In a few historical accounts, black rain has been described as thick, almost tar-like, coating leaves and rooftops with a sticky darkness that resists washing away. Some of these reports come from centuries ago, before industrial soot was common. What caused those older black rains remains genuinely unclear. Volcanic ash carried far from an eruption is one possibility. Vast peat fires burning slowly underground for months are another. Neither theory fits every case. The surface of a landscape after a black rain has a haunted look. Fields that were bright green in the morning wear a dusky film by afternoon. Pale flowers hold small black speckles at the base of each petal. Ponds show a dark ring at the waterline where the residue has settled. Birds bathing in puddles emerge with stained feathers, and people, gathering samples in jars or cups, hold their small dark collections up to the light and try to guess what they have caught. The problem, again and again, is that the samples do not always agree. Two black rains falling in different places may contain very different materials. Even two samples from the same storm can differ, depending on where they were collected. Modern instruments can identify carbon, ash, minerals, spores, and traces of chemicals, yet identifying the ingredients does not always reveal the full path. Where the material began, how it climbed, how far it traveled, and why it fell in that particular field on that particular afternoon. So the black rain settles, and the question settles with it, into the quiet, dark soil of the unresolved. There are stories scattered across the last 2 centuries of enormous chunks of ice falling from skies that were, by every account, mostly clear, not hail, which comes from thunderstorms and arrives in showers of small stones. These are single, heavy blocks, some the size of a grapefruit, some the size of a bowling ball, a few, if the old records can be trusted, the size of a small car. They land in fields, punch holes through barn roofs, shatter on country roads, and leave the people nearby staring up at a sky that offers no clear answer. Scientists have a name for these strange objects. They call them megakryometeors, which simply means very large ice meteors. The word sounds grand, but the mystery beneath it is quite humble. Nobody is fully sure where they come from, and the deeper you look into the question, the stranger the story becomes. For a long time, the easy answer was aircraft. Planes, flying at high altitudes, sometimes leak water from their systems, and that water can freeze into ice on the outside of the fuselage. When the plane descends into warmer air, the ice breaks off and falls. This does happen. It has been documented many times. But when researchers began studying the biggest ice falls carefully, they found something odd. Some of the ice chunks landed in places where no aircraft had passed. Some fell before airplanes even existed, and the internal structure of the ice, the way its layers were stacked, did not always match what you would expect from a slow build-up on a wing or a wheel well. So the question opened again. One idea, put forward by a Spanish planetary scientist, is that certain unusual weather patterns can allow ice to grow very high in the atmosphere, in the cold layer called the tropopause, where the air stops rising and begins to spread out sideways under just the right conditions, he suggested. Water vapor might gather and freeze in layers, building up a stone of ice in the sky, held aloft by strong updrafts until it grows too heavy and drops. The hypothesis is careful and thoughtful, but it remains unconfirmed. Other researchers wonder if the numbers work. They ask how a lump of ice that large could form without a thunderstorm to lift it, and why such falls happen even on days when the sky seems calm. A competing view is simpler. It suggests that most large ice falls really are from aircraft, and that the historical cases before flight are either exaggerated, misremembered, or the product of unusual hailstorms whose parent clouds drifted away before witnesses looked up. This is a reasonable position. Human memory is imperfect. Old newspapers loved a strange tale, and hail, in rare cases, can grow to astonishing size when caught in a powerful storm updraft, tumbling up and down inside a cloud, gathering layer after layer of ice, like the rings inside a tree. That even this explanation leaves gaps. Some of the modern ice chunks, gathered quickly and studied in labs, show layers of remarkable clarity, alternating with cloudy bands and traces of dissolved gases that seem to point to a slow, high-altitude origin rather than a violent tumbling inside a storm cloud. The samples are rare. They melt quickly. By the time scientists arrive at the crash site, most of the evidence is a puddle in the grass. There is a quiet drama to these events. A farmer walks out to check on a cow at dusk and finds a crater the size of a dinner plate in the soft earth. Inside it, half melted, sits a lump of pale ice with faint blue layers. The sky above is streaked with high cirrus, thin and calm. No storm, no plane visible or audible, just the object, cooling the ground around it, releasing a slow drip of water that will be gone by morning. The color of these ice stones is often described in careful detail by the people who find them. Some are milky white all the way through. Some have a bluish core wrapped in cloudier white. Some show tiny dark specks, which laboratory analysis has occasionally traced to dust or pollen frozen inside. That dust hints at long journeys through the upper atmosphere, where fine particles from deserts and forests drift for weeks at a time. What ties the fall of ice to the fall of fish, frogs, and colored rain is this shared quality of coming from a sky that seems, at the moment of the event, to hold no reason for what it delivers. The atmosphere is far deeper and stranger than the clouds we see from the ground. Somewhere in those high, thin layers, processes we do not yet fully understand are gathering material, holding it, and letting it go. And now and then, a piece of that hidden work arrives at our feet, quietly, without war. High in the mountains, where the air thins and the wind moves in slow, patient sweeps, the snow does not always fall white. Sometimes it arrives pink, sometimes red, sometimes a soft, dusty yellow, as if someone had brushed pollen across the peaks in the night. Travelers have written about these colored snows for thousands of years, and the sight still startles hikers today. A field of fresh powder can turn the color of watermelon by afternoon, staining boots and gloves, glowing faintly under the sun. The rhythms behind these colored snows are strange and slow. They pulse with the seasons, with the winds, with the melting of ice. In the high ranges of the Alps, the Rockies, the Andes, and the Himalayas, spring is often when the snow blushes red. As the surface warms, tiny green algae that have slept all winter inside the ice begin to wake. When they wake, they change. They build a red pigment inside their small bodies, a kind of natural sunscreen that shields them from the harsh mountain light. The more sun they drink in, the redder they grow. And so the snowfields turn slowly pink, then rose, then deep crimson, like a bruise spreading across the white. This is one theory, and a strong one. Scientists have studied these algae for over a century, and the species has a Latin name that means, roughly, snow that turns to blood. Yet, even here, in a mystery that seems partly solved, questions remain. No one fully understands why some slopes turn red while others, only a valley away, stay pure white. No one is sure how the algae survive the deep cold, or how they travel from peak to peak, or whether the winds carry them across whole continents. Some researchers wonder if the spores ride the same high-altitude rivers of air that lift dust and pollen thousands of miles from home. Others think each mountain range keeps its own quiet population, waking and sleeping with the seasons. Then there are the colored snows that are not made by living things at all. In the mountains of Central Asia, snow sometimes falls the color of pale coffee, tinted by dust lifted from the great deserts to the south. In the Alps, a soft orange snow has fallen more than once, carrying grains from the Sahara across the Mediterranean and up into the high passes. These storms follow their own cycles. When certain wind patterns line up just right, the dust rises. When they shift, the snows return to white. Some years bring many colored falls, other years bring none. The rhythm is real, but no one can predict it with any certainty. The strangest colored snows are the ones that do not fit either explanation. There are old records of green snow, blue snow, and even black snow falling in remote places, sometimes smelling faintly of sulfur, sometimes of nothing at all. Some of these events likely came from industrial soot carried on the wind. Others may have come from volcanic ash drifting far from its source, but a few remain unexplained, tucked away in old journals and village memories, with no clear cause ever found. What makes the colored snows part of a cycle is the way they return. Year after year, the same slopes in the same ranges bloom pink in the same weeks of spring. Year after year, certain passes in the Alps catch their dusting of desert orange. The earth breathes slowly, and these strange snows seem to breathe with it. They are tied to the melting of ice, the turning of the wind, the awakening of tiny lives that have waited all winter under a blanket of white. There is a quieter question here too. As the algae grow, they darken the snow. Darker snow absorbs more sunlight. More sunlight means more melting. More melting means more liquid water, which the algae need to thrive. So the colored snows may speed up the very melting that feeds them. How much this matters for the world's glaciers is still being studied. Some researchers believe the effect is small. Others suspect it could be growing as the mountains warm. The answer is not yet in. For now, the colored snows remain, one of those gentle mysteries the earth offers up without explanation. They arrive quietly, tint the peaks for a few weeks, and fade as summer melts the slopes down to bare stone. Somewhere in a high valley tonight, algae are sleeping inside the ice, waiting for the light to change. And somewhere else, dust from a distant desert is drifting slowly through the sky, on its way to a mountain it has never seen, ready to settle in soft colored layers upon the snow. The strangest sky falls rarely arrive alone. When fish tumble onto a village, so do bits of pondweed. When frogs land on rooftops, tiny snails sometimes come with them. The sky, it seems, gathers up whole small worlds and sets them down somewhere new. And among those small worlds, a few of the visitors are stranger still than the fish and the frogs. There are old reports, quiet ones, of jellyfish falling from the sky. Not many, but enough to make people wonder. In the late 19th century, in the American town of Bath, a soft rain of small clear creatures reportedly dropped over a lawn. Witnesses described tiny gelatinous bodies, no larger than a coin, scattered across the grass like beads of glass. Some observers thought they were true jellyfish. Others thought they were something else, some drifting freshwater animal that only looked the part. The samples were never properly kept. The truth slipped away, as truths often do when nobody thinks to save them. Worms have a longer record in the mountains of Norway, in the plains of Louisiana, in the fields of Scotland. Farmers have found their pastures suddenly covered in wriggling pink threads after a storm. Sometimes the worms are alive, sometimes they lie still, tangled together in soft heaps. One theory suggests these worms were never really airborne at all. Heavy rain, the idea goes, simply drives them up out of flooded soil, and people notice them all at once and assume they fell. Another theory holds that strong updrafts near a storm cell can lift lightweight creatures from wet ground and scatter them a short distance away. Which explanation fits any given case, we usually cannot say. The neighbors of skyfalls are not only animals, they are also the things that live with those animals. Pond water carries algae, and algae sometimes come down in the rain that carries the fish. Small crustaceans, no bigger than a grain of rice, have been reported among falls of tadpoles. Leaves, twigs, feathers, and the fine mud of a shallow pond can appear on rooftops far from any pond at all. It is as though the sky lifted a small ecosystem, held it briefly, and let it go over unfamiliar ground. This raises a gentle puzzle. If a waterspout or a whirlwind is truly the cause of these falls, we would expect it to lift everything from a pond or a shallow lake, not just one kind of creature. Yet many reports describe surprisingly clean falls. Only fish, only frogs, only worms, with little else mixed in. Some researchers wonder if the sorting happens in the air itself, with heavier bodies dropping first and lighter ones carried farther. Others wonder if witnesses simply notice the dramatic creatures and overlook the mud and weeds that fell with them. Both ideas may be partly right, neither is fully proven. The neighbors also include the microscopic rainwater collected after unusual storms, has sometimes been found to hold spores, pollen, bacteria, and tiny fungal threads that do not match the local plants. Some of this material travels enormous distances on high winds. Dust from the Sahara has reached the forests of the Amazon. Pollen from Asian pine trees has been found in ice cores from the far north. When a strange rain falls, part of what comes down may have started its trip weeks earlier, thousands of miles away, riding rivers of moving air that we cannot see from the ground. Sit for a moment with the picture, a quiet field after a storm. Fish flopping softly in the wet grass, tiny worms coiled beneath them, a dusting of pale pollen no one can quite place. Overhead, the last clouds slide away, showing patches of clean blue. Somewhere in that field is a small gathered sample of ponds and forests and deserts, all mixed together by winds that traveled paths we can only guess at. The mystery is not only what fell, but what came with it. Every strange fall is a small message from a wider system. The storm that carried the fish also carried the algae. The whirlwind that lifted the frogs also lifted the pond mud. The upper air that dropped the worms also dropped the pollen. Each fall connects one small patch of ground to another, sometimes across surprising distances in ways we still cannot fully map. Perhaps that is why these events feel so strange. They remind us that the sky is not empty. It is a slow, quiet river of small living things moving above our heads all the time. Now and then, that river spills, and when it spills, it leaves its neighbors, all of them, scattered on the grass for someone to find in the morning. Long before weather stations and satellites, before anyone measured a raindrop or named a cloud, people were already writing down the strangest things that fell from the sky. Some of these accounts are thousands of years old. They come from clay tablets, from crumbling scrolls, from the careful hand of monks who believed they were recording the will of heaven. You read them today, in soft translation, you find something quietly astonishing. Many of the strange falls we still argue about now were being described in almost the same words 2,000 years ago. The Roman writer Pliny the Elder, who lived in the 1st century, gathered reports of showers that no one could explain. He wrote of rains of milk and blood, of flesh and wool, and of iron falling in Lucania. He treated these events as curiosities of the natural world, worth writing down and passing on. He did not always believe them, but he noted them faithfully. His pages are among the oldest surviving records of the same puzzles that still gather dust in modern journals. Older still are the accounts from Greek writers. Athenaeus preserved a fragment describing a fall of fish that lasted 3 days in the region of Chersonesus. The fish, he wrote, were of the kind found in nearby waters. Whether the story grew in the telling, we cannot know. The parchment is old, the ink is faded, and the witnesses have been silent for more than 2,000 years. Yet, the description matches, in strange detail, the modern reports from Honduras, from Australia, from the small towns of the American South. Chinese chronicles reach back even further. Court historians kept careful records of omens and unusual weather, because such things were thought to reveal the mood of heaven itself. Among these entries you find showers of grain, of hair, of small stones, of colored dust. Some fell during dynasties long since crumbled to memory. One record from the Han period describes a rain of what the scribe called red sand, thick enough to coat the courtyard tiles. Modern researchers suspect it was desert dust carried on the great winds from the west. But the scribe did not know that. He only knew the color of his tiles that morning. Medieval European chronicles are perhaps the richest source of all. Monks in quiet abbeys wrote down everything unusual that touched their village or their diocese. In the year 1177, an English chronicler recorded a fall of blood-colored rain. In 1233, another described a shower of small fish near the coast. In 1578, a chronicle from Bergen speaks of yellow mice tumbling from a storm cloud, though most modern readers suspect this was a mistranslation or an embellishment. Still, the reports pile up, decade upon decade, in careful ink. The Arab world produced its own careful observers. Scholars in Baghdad and Cairo wrote of strange showers with the same precision they brought to astronomy and medicine. A 10th century text describes a fall of small frogs so thick that a whole road was covered. The writer, trained in natural philosophy, offered a theory. He suggested a great wind from the sea had lifted them and carried them inland. This is essentially the same waterspout hypothesis proposed by scientists today. The idea, it seems, is older than we sometimes remember. What is quietly striking about all these ancient reports is how similar they are to modern ones. The same fish, the same frogs, the same red rains, the same yellow dusts, across continents, across centuries, across languages that no longer exist. People looked up at the sky and saw the same puzzles falling toward them. Whatever process is at work, it has been at work for a very long time. It has been sending its small offerings into human courtyards since the earliest days of writing. Some researchers now go back through these old accounts, looking for patterns. They compare dates with historical weather records, where any exist. They map the reported falls against known storm tracks, against volcanic events, against the seasons of migration for birds and fish. A few weak patterns emerge. Many do not. The old records were not written for science. They were written for memory, for wonder, for the keeping of strange days. And so the ancient scribes leave us with a gift and a puzzle. They tell us that the sky has been doing this for as long as anyone has been watching. They tell us we are not the first to look up in confusion. They do not tell us why. That question, older than empires, older than the languages the scribes used, still hangs quietly in the air above us, waiting for someone, someday, to finally understand it. For as long as people have tried to explain fish and frogs falling from the sky, one answer has kept returning. The answer is the whirlwind somewhere out on the sea or above a shallow pond. A spinning column of air reaches down and lifts water into itself. Inside that spinning column, small living things are carried upward. Then, miles away, the wind loses its grip and the strange cargo comes down. The most famous version of this idea involves the waterspout. A waterspout is a tall, twisting funnel of wind that forms over warm water. From a distance, it looks like a slender grey rope hanging from a cloud. Up close, the base of it churns the sea into a ring of mist and spray. Inside, the air spins fast enough to lift droplets, foam, and sometimes small creatures into the sky. Scientists have watched waterspouts for a long time, and they know these funnels can indeed pull water upward. Sailors have described seeing the surface of the sea rise into the funnel like a living thing. The spinning air acts almost like a straw, so the picture seems simple. A waterspout crosses a fish-filled bay, sucks up a school of small fish, drifts inland with the storm, and drops them onto a village. The story fits, and for a long time it satisfied most curious minds. The quiet details of the theory, though, are where it starts to feel less certain. When researchers look closely at reports of fish falls, they notice something strange. The fish are often all the same size. They are often all the same species. They arrive in a neat patch, not scattered across a wide zone. A whirlwind, by its nature, should be messy. It should lift mud, weeds, pebbles, insects, and fish together. It should drop them in a long, smeared trail. The neatness bothers people who study these events. A waterspout does not politely sort its cargo by shape. Yet witnesses often describe a small, tidy square of ground, covered in identical fish, with no seaweed or debris around them. Some researchers wonder whether the sorting happens naturally as the objects fall. Heavier things drop first, lighter things drift farther. Perhaps the waterspout does the lifting, and gravity does the sorting on the way back down. Others are less convinced. They point out that the nearest body of water is sometimes far away from the fall site, further than any known waterspout has ever traveled. They also note that many fish falls happen under calm skies, with no reported storm nearby. A whirlwind theory needs a whirlwind, and sometimes there simply is not one. There is another quiet detail worth resting on. Waterspouts weaken quickly when they move over land. Their spinning core depends on warm, moist air from the sea. Once that supply is cut, the funnel unravels within minutes. So how does the lifted cargo stay aloft long enough to travel any real distance? One idea is that the cargo does not stay in the funnel at all. Instead, it gets flung upward into a thunderstorm above, where powerful updrafts hold it high in the clouds. There, it might drift on the winds for hours before finally falling. This layered version of the theory brings its own quiet puzzles. Small fish held high in a cold cloud should freeze, yet witnesses often describe the fallen fish as still alive, flopping on the grass. Some accounts mention them being cold or slightly stunned, but very much breathing. If they truly rode inside a thundercloud, how did they survive the height and the chill? Scientists have proposed gentler versions of the whirlwind. Dust devils, small land-based whirlwinds, can lift light objects a short distance. Gust fronts along the edge of a storm can loft insects and spiders into the air. These smaller forces might explain smaller falls. They might not explain the large dramatic ones. There is something soft and beautiful in the picture, all the same. A quiet coastal morning. A far-off funnel of wind, thin as a thread, brushing the surface of a shallow lagoon. A shimmer of little silver fish rising into the mist. The wind carries them inland across fields. No one is watching. Somewhere over a sleeping town, the wind loosens, and the fish begin their long, slow descent through the cool morning air. The whirlwind theory may hold part of the answer. It may hold most of it, or it may only explain some cases, while others still wait for a different kind of explanation. For now, the neat little patches of fish on distant lawns remain a puzzle that our sharpest instruments have not fully solved. The spinning wind gives us a shape for the mystery, but not, quite yet, its full and settled course. For a very long time, people who saw red rain believed they were witnessing something holy, or something terrible, or both. The stains on their clothes, on their roofs, on the pale stones of their courtyards looked like blood, and blood in the sky meant meaning. It meant a message. It meant the gods were speaking, or that some far-off battle had bled into the clouds. The idea that the color might come from something as ordinary as dust, blown across a sea from a distant desert, was not an idea most cultures reached for. Dust was too small. Dust was too dry. Dust could not, in the imagination of an ancient farmer, fall from a rain cloud 1,000 miles from home. The first hints that something more earthly might be at work came slowly. Sailors were often the earliest witnesses to the true story. They spent weeks at sea And they noticed things landsmen did not. They noticed that when the winds blew from the south, from the direction of Africa, their sails and decks would sometimes gather a faint reddish film. They noticed that the air itself seemed to thicken, to take on a color, to soften the light of the sun. Some captains kept careful logs of these strange dustings, sweeping the powder into small jars, sealing them with wax, and carrying them home to curious naturalists. In the 1800s, a few of those naturalists began to look at the powder under early microscopes. What they saw surprised them. The red was not blood. It was not sulfur. It was tiny grains of mineral, rounded and worn, mixed sometimes with the shells of microscopic creatures that live in warm, shallow seas. The mineral matched the soils of North Africa. The shells matched the ancient seabeds that lie beneath the Sahara. Slowly, a picture began to form. The wind, it seemed, could lift enormous quantities of desert into the sky and carry them across oceans. One of the great early observers of this was the German naturalist Christian Gottfried Ehrenberg. He collected dust samples from ships all across the Atlantic. He studied them for years. He found the same species of tiny fossils again and again, no matter where the ship had been sailing, so long as the wind had come from the right direction. He proposed that dust from the Sahara traveled thousands of miles on high air currents, sometimes reaching the Caribbean, sometimes reaching northern Europe. Many of his contemporaries found the idea hard to believe. A desert on one continent staining rain on another seemed too grand a claim. Yet the evidence kept arriving. Farmers in southern Europe reported reddish mud settling on their olive groves after storms. Alpine climbers found pink layers pressed into old snow, layers that matched the chemistry of African soil. A quiet consensus grew, section by section, decade by decade, that some of the strangest colored rains in human history were simply the sky delivering distant dirt. The mystery, though, did not close. It only shifted, because not every red rain fits this explanation. The 2001 red rain of Kerala in southern India was studied carefully by chemists who expected to find African dust or local red soil. What they found instead were tiny round cells, red in color, that resembled some kind of living material. One team argued the cells were an algae blown up from local lichens. Another team wondered aloud whether they might be something stranger, something not yet named. The debate has continued for more than 2 decades, with samples passed between laboratories, with new tests run, with careful papers written on both sides. No single answer has closed the case. So the history of discovery in this small, strange corner of science is a history of partial answers. We now know that some red rains are desert dust, lifted by storms in the Sahara or the Gobi, riding rivers of high wind for thousands of miles before falling gently on a foreign field. We know these events are common, predictable, even mappable by modern satellites that watch the plumes drift across oceans in slow orange spirals. That much has moved from mystery into ordinary science. But other red rains still resist. Their chemistry does not match any nearby desert. Their particles look like nothing dust should look like. The old explanation, so hard won by those 19th century naturalists, does not stretch to cover every case. And so the sky keeps a portion of its secret. The instruments have grown better. The microscopes now see the shape of a single molecule. Yet somewhere, above some quiet village, a rain falls that no laboratory has fully explained, and the old feeling returns, faintly, that the clouds may still be carrying a message we have not yet learned to read. The strangest thing about the red rain that fell over Kerala was not its color. It was what scientists found when they looked at the water under a microscope. Tiny round shapes floated in the fluid. They looked like cells. They had walls and inner structures, and they clustered together the way living things sometimes do. When researchers counted them, they found billions of these red particles in a single liter of rain. The sky, it seemed, had delivered a dense soup of something alive. This was where the puzzle deepened. Most rain, when studied closely, does contain small traces of biological material. Pollen grains drift in it. Bacteria ride the droplets. Fungal spores hitch a quiet ride from forest to field. The air above our heads is not empty. It is a slow, invisible river of tiny living things, always moving, always settling gently back to the ground. In this sense, life falling from the sky is ordinary. It happens every time it rains, everywhere on Earth. But the Kerala samples were different in scale. The red cells were not scattered specks among clear water. They were the water. They colored it deeply, like weak tea or watered wine. And when researchers tried to identify them, the answers did not come easily. One team suggested the cells were spores from a local algae called Trentopolia, a reddish organism that grows on tree bark in humid parts of southern India. Their argument was careful. They matched the size, they matched the color, they matched a known local source. Yet other researchers found the explanation incomplete. They pointed out that the cells seemed to lack DNA in the usual amounts, at least in some early tests. They noted that the cells appeared to survive very high temperatures, far hotter than most living things can tolerate. A few researchers wondered aloud whether the particles might not be ordinary spores at all. The debate stretched on for years, quiet and technical, with new samples analyzed and old conclusions revisited. The strangeness only grew when scientists began looking at rainwater in other places with fresh curiosity. Rain from ordinary storms, in ordinary countries, on ordinary days, turned out to contain living cells that could still grow when placed in a dish. Bacteria plucked from clouds could reproduce in a laboratory. Some of these bacteria seemed unusually good at surviving cold, dryness, and sunlight. A few researchers began to wonder whether certain microbes might actually live in clouds, drifting from droplet to droplet, feeding on trace chemicals in the moist air. The idea is still contested, but the samples keep coming, and the little cells keep growing. Consider what this means for a moment. Lying in the dark, when rain falls on your window at night, it is not simply water. It carries dust from distant deserts, salt from far oceans, pollen from forests you have never walked in, and tiny living cells whose full identity we still do not know. Every gentle patter on the roof is a delivery from the whole sky, a small settling of the world onto itself. The counterintuitive part is that the atmosphere, which seems so thin and empty, is thick with quiet passengers. Winds carry bacteria across oceans. Storm updrafts lift microbes many kilometers into the air. Some of these tiny cells have been found high above the clouds, at altitudes where the air is cold and the sunlight is harsh. How they survive up there is another open question. Some may simply drift dormant, waiting to fall. Others may be truly at home in the sky, in a way we're only beginning to understand. The red rain of Kerala sits at the far end of this quiet spectrum. Whatever fell that year was almost certainly biological in origin. It was almost certainly lifted by wind from some source on Earth. The most careful current view is that local algae spores were swept up by strong updrafts, perhaps mixed with meteoric dust, and later released in unusual concentrations by particular clouds. This is a reasonable idea, supported by real evidence. It is also not the only idea, and some of its details remain unsettled. What stays with us is the reminder that the sky is not clean. It is full of small living things. Sometimes, under strange conditions, those small things gather in numbers we can see with the naked eye, and they color the rain, and they arrive at our feet like a message written in a language we cannot quite read. The message says only that the world is more crowded and more connected than it usually appears. Where exactly the writers of the message live, and how they came to fall together on one particular afternoon, remains a puzzle, still gently turning in the minds of those who study rain. On a warm afternoon in Bath County, Kentucky, in the spring of 1876, a woman named Mrs. Crouch was outside making soap in her yard. The sky above her was clear and quiet. Then, without warning, small pieces of something soft began to fall around her. They landed on the grass. They landed on the fence rails. They landed on the roof of the cabin. Each piece was about the size of a snowflake, but heavier and pinkish red. She thought at first it might be a strange kind of snow. But it was spring, and the day was mild. When neighbors came to look, they found the yard scattered with these small flakes. Some brave souls picked them up. 2 men, so the story goes, even tasted them and reported that the flakes were something like mutton or venison. Word of the fall spread quickly. Samples were gathered and sent away to scientists in the eastern cities. What arrived at those laboratories was a small, strange puzzle that no one has ever fully closed. The Kentucky meat shower is one of the most quietly famous strange falls in American history, and it connects, in its own soft way, to nearly every thread we have been following through this long night. The question is the same question we keep meeting. How does something end up in the sky that has no business being there, and then come down, gently, onto the ground of a peaceful farm on a clear afternoon? Several theories were offered at the time, and several remain on the table today. The most widely repeated explanation is a strange one. A group of vultures, flying high overhead, may have startled and disgorged the contents of their stomachs. Vultures are known to do this when threatened. If a flock had been feeding and something spooked the lead bird, the whole flock might have released a shower of half-digested material into the air below. The wind and the height could have spread that shower across a wide patch of ground. Another theory pointed to a substance called nostoc, a kind of jelly-like algae that swells up after rain and can appear as if it fell from above. Nostoc has fooled observers for centuries. It grows quietly on the ground, invisible when dry, and then puffs up into pale, fleshy blobs after a storm. Some scientists in the 1870s suggested the Kentucky flakes were simply nostoc, misidentified by startled eyes. A third view came from those who examined the samples under early microscopes. They reported seeing what looked like animal tissue, muscle, cartilage, perhaps even lung. If they were right, nostoc could not be the answer. That would send the mystery back to the vultures, or to something stranger still. None of these theories fully satisfies. The vulture idea fits the biology, but strains the meteorology. No one in Bath County reported seeing birds that day. The nostoc idea explains the mystery away too neatly and does not match the tissue reports. And the tissue reports themselves came from instruments and methods that were young and not always reliable. What makes this event feel important on a quiet night like this? One is how it ties the whole strange sky together. A shower of meat in Kentucky is not so different in its shape from a shower of fish in Yarrow, or a shower of frogs in a French village, or a red rain in Kerala. Each event asks the same question. How did that thing get up there? Each event points to the same wide invisible system above our heads, where wind and heat and pressure move material in ways we still do not fully map. The sky, when you think about it this way, is not empty. It is a slow, tall river. Dust from a desert on one continent falls as color on the snow of another. Spores from a forest ride, an updraft, and land in a distant field. Living cells, small enough to catch a breeze, drift for days at heights we cannot easily reach. And sometimes, rarely, something larger goes up too. A small fish, a frog, a stone of ice, a pink flake on a spring afternoon in Kentucky. The forces that move the ocean also move the air. The forces that stir a thunderstorm also lift the pollen. The forces that carry sand across a sea also carry, on very rare days, things that startle us when they land. It is one long, quiet, tangled system, working above us all the time. We do not fully understand it. We may never fully understand it. And so the meat shower of Bath County remains, like so many other strange falls, an open page, waiting patiently for someone to read it. Ice from the sky has always fallen, but the ice itself seems to be changing. Hailstones the size of peas were once the common story of a summer storm. Farmers would sweep them off the porch and lose a few tomato plants, and life would go on. Yet in recent decades, the record books have swelled with stones the size of golf balls, then tennis balls, then grapefruits. Something in the upper air is shifting, and the frozen oddities that tumble down are quietly telling us so. To understand why, it helps to picture how a hailstone is born. Deep inside a tall storm cloud, tiny droplets of water get swept upward on powerful currents of rising air. They freeze onto small bits of dust or ice, then fall a little, then get lifted again, gathering more frozen layers each time. If you slice a large hailstone in half, you can see the rings, like the rings of a tree, each ring a record of a trip up and back down inside the cloud. The bigger the stone, the more trips it made, and the stronger the wind currents must have been to hold it up there. That is where the mystery begins. To keep a grapefruit-sized stone aloft long enough to grow, the updraft inside the cloud must roar upward at more than 100 miles per hour. Storms that violent used to be rare. Now they seem to appear more often, in more places, and in seasons where big hail was once almost unheard of. Some researchers wonder if a warmer, lower atmosphere is feeding storms with more moisture and more energy, allowing them to build taller and hold larger stones. Others point out that our record keeping has also improved, with cameras in every pocket and radar in every county. Perhaps we are simply seeing what was always there. Both explanations may be partly right, and the balance between them is still an open question. What is clearer is that the stones themselves have grown stranger in shape. Old accounts describe hail as smooth and round, like frozen peas. Modern photographs show jagged crowns, thick spikes, and lumpy shapes that look almost sculpted. When a stone rides the updrafts for many minutes, it collides with smaller droplets that freeze onto its surface in odd places, forming little icy horns. The wilder the storm, the wilder the shape. There are other frozen oddities that fall without any storm at all. Sometimes a lump of ice, the size of a bowling ball, crashes down through a roof on a calm, clear afternoon. These are called ice meteors or megacriometeors, and they remain one of the strangest puzzles in atmospheric science. They are made of ordinary water ice, layered like hail, yet they arrive from a sky with no visible cloud. One theory suggests they form in the upper atmosphere under rare temperature and moisture conditions we do not fully understand. Another idea points to airplanes whose wings can shed ice in flight. Yet many of these boulders have been reported far from any flight path, and their inner layers look nothing like ice from a plane. The question sits, unresolved, waiting. The colors of frozen falls have also changed in recent years. Pink snow, sometimes called watermelon snow, now blooms across more mountain slopes each summer. It is tinted by tiny algae that thrive on warming ice. As the ice retreats, the algae spread, and the snow that falls on top can carry their pigment down onto villages below. Whether this is a new pattern or simply a more widely noticed one, no one can yet say for certain. Even the timing of frozen falls is drifting. In some regions, hail seasons now begin earlier in spring and stretch later into autumn. In others, hail seems to be arriving less often, but in bigger, fiercer bursts. Weather scientists watch these shifts with quiet fascination, gathering data year after year, trying to see the pattern beneath the noise. The atmosphere is enormous, its behavior tangled, and a single decade of observations is a very short window. What remains true is that ice from the sky has always been a kind of message. Each stone carries its history in its rings. Each strange shape hints at the winds that shaped it. Each unexplained boulder of ice, arriving from nowhere, reminds us that the sky above our heads is still a place we do not fully understand. It is changing, slowly and quickly at once, in ways we are only beginning to read. And somewhere tonight, deep inside a distant cloud, another small piece of ice is rising and falling and rising again, patiently gathering its own quiet story. In certain parts of the tropics, after a long hot afternoon, the sky can take on a color that seems almost impossible. Not gray, not the soft silver of a normal storm, something closer to green, a pale, glowing green that sits behind the clouds and turns the whole world into an old photograph, tinted by hand. Farmers in the fields look up, fishermen on the coast pause and squint. The light has changed, and no one is quite sure why. Green skies are real, and they are strange. They tend to appear before very heavy storms, especially the sort that carry hail. But the exact cause of that green glow remains an open question among people who study weather. One idea is that the setting sun, low in the sky, sends its long red rays through the storm. Inside the storm, the water and ice scatter blue light, red plus blue, mixed and softened by thick cloud, can look green to the human eye. It is a trick of color, painted by the water itself. Another idea is that the deep water content inside the tallest storm clouds acts like a filter. Thick water absorbs red light and lets green pass through. The taller and wetter the cloud, the more green light leaks out toward the ground. If that theory is right, a green sky is a kind of message. It is the cloud telling us, in color, that it holds an enormous amount of water and ice high above. Which parts of these ideas are correct, and how they combine, is still not fully settled. Now imagine that same green light falling on a rain that is not quite ordinary. In some tropical regions, people describe rain that carries a faint greenish tint of its own, not just the light around it, but the water itself. When collected in a white bowl, the drops sit with a soft color that fades slowly over hours. The most common explanation is pollen. Certain trees release enormous clouds of fine yellow-green grains during their flowering season. Wind lifts the pollen into the air. A passing storm sweeps it back down, mixed into every drop. A second explanation points to algae. Tiny green algae live in surface waters, in damp soil, on the bark of trees. Strong winds and rising warm air can carry these microscopic cells upward. When rain forms around them, the drops fall with a faint living color inside. Which source dominates in any given storm is often unclear. The samples are usually rinsed away before anyone can study them carefully. The question of how much of tropical rain carries living passengers is still, in many places, only partly answered. The light in these moments does something quiet and beautiful. It turns the ordinary into something worth watching. A wet leaf under a green sky looks polished, almost glass-like. Puddles catch the color and hold it, mirrors of a strange afternoon. The trunks of palm trees darken. The white walls of houses take on a soft, cool wash. Everything feels held inside a single tint, the way old films sometimes hold a single mood in every frame. Sailors in past centuries wrote of green light before great storms at sea. They took it as a warning. Modern weather watchers still see it, still note it, still argue gently about what it means. Some storms with green skies produce hail the size of marbles. Others produce nothing more than heavy rain. The color, on its own, is not a reliable sign of danger. It is only a sign that something unusual is happening high up, in air the eye cannot reach. The green rain, when it comes, is often warm. It falls in fat drops that plink against broad tropical leaves. Children run through it. Old people watch from doorways. If a small pool collects on a stone bench, and someone looks closely, they may see the faintest cloud of color swirling inside. By morning, the color is usually gone. The water has soaked away, or evaporated, or the pollen has settled into a thin film on the ground. The event leaves almost no trace. That is part of why the science is slow. These falls happen without warning, in scattered places, and disappear quickly. Researchers cannot always be present with clean bottles and careful notes. The best records often come from people who simply looked up, noticed the light, and remembered. Their observations are gentle clues, gathered across decades, pointing toward answers that have not yet fully arrived. For tonight it is enough to picture that green light, a tropical afternoon, a slow, warm rain, leaves shining, the whole world tinted by something high above, something we still do not entirely understand. Listen for a moment to the sounds a fish fall might make. Before the fish arrive, there is often only the soft hush of an ordinary storm. The wind moves across the roofs of a small town, brushing palm leaves and metal sheets. Then comes a different noise, a wet, uneven patter. Not the round drumming of rain, but something heavier and more scattered. Small bodies striking tin, striking stone, striking the soft mud of a garden path. Witnesses across the years have described this sound in nearly the same way. A rain that does not sound like rain. In coastal parts of Honduras, villagers speak of the lluvia de peces, the rain of fish. For generations they have gathered small silver fish from the grass after certain heavy storms. The sound they describe is soft, almost polite, a gentle slapping against wet ground. Children hurry out with baskets. Adults follow, stepping carefully. No one seems surprised. The fish are usually small, often the length of a finger, sometimes still alive, sometimes long past living. Where they come from remains an open question, though several theories try to answer it. One idea is that a strong waterspout forms over a nearby lagoon or river, lifting shallow water and everything in it. The spinning column carries the fish upward, then loses its grip, and the little bodies fall miles from where they began. This theory fits many cases around the world. It explains why the fish are usually small and why they tend to be of a single species. whatever was closest to the surface when the wind reached down. The sound of a waterspout itself is a low, throaty roar, the kind sailors have described for centuries. A competing theory suggests that in some places, the fish never really flew at all. They may have swum. During heavy rainfall, small streams and flooded fields can join together into shallow moving water that reaches yards and gardens. Fish already living in nearby ditches could ride these new channels, arriving after the storm as if dropped from above. In this version, the sound the villagers hear is not falling fish, but flowing water, carrying them along. Both explanations remain possible. In many towns, no one has ever caught the moment itself on film. The Honduran case is one of the oldest recurring reports of its kind. Local tradition places the first falls in the 1800s, though written records are patchy. Scientists who have visited say the fish appear to be a freshwater species, which raises another puzzle. The nearest ocean is close by, but the fish do not seem to be ocean fish. If they came from inland waters, the winds would have had to travel a long, curving path. If they came from underground streams, the mystery deepens further. The question of their journey upward remains genuinely unresolved. Listen also to the sounds inside a thunderstorm itself. Powerful updrafts can move at speeds faster than a car on a highway. Inside those rising columns of air, hail grows layer by layer, tossed up and down until it is heavy enough to fall. Some researchers wonder whether a small fish caught in such a column could be lifted the same way. The idea is not impossible, but no one has ever recorded the moment a fish entered a cloud. The sound of that lifting, if it happens, would be lost inside the roar of the storm. Other reports come from places far from Honduras. Villages in India, Australia, and the American South have all described sudden falls of small fish after heavy weather. In each case, the sound is similar: a wet scatter, a brief drumming, then silence, and a strange harvest lying in the grass. Some falls involve only a handful of fish, others cover fields the size of a small park. The variation itself is a clue, though scientists disagree about what it means. There is also the quieter sound that comes afterward, the soft rustle of wet grass being searched, the clink of a bucket, the low voices of people trying to decide whether to eat the fish or bury them. In some places, the fish are considered a gift, a small blessing from the sky. In others, they are treated with caution, gathered but not consumed. Folklore has grown around the sound for centuries, filling in what science has not yet been able to explain. Perhaps one day a camera will catch the full arc of such a fall. Perhaps a weather balloon will drift through a rising cloud and find small silver bodies suspended inside. For now, the sound of fish falling on a village roof remains one of the strangest and most gentle noises earth occasionally makes. A soft patter, a scattered rain, and a question that no one has yet fully answered. There is a strange arithmetic hidden inside the sky. When yellow powder falls across a village and coats the rooftops in a pale gold dust, the numbers behind that event are older than any human record. Pollen grains, for example, measure only 20 to 50 micrometers across. That is smaller than the width of a single human hair. Yet a single pine tree can release 5 billion of them in one spring season. Multiply that by a forest, and the arithmetic begins to explain how the sky can turn yellow overnight. For centuries, people in Europe and Asia described sulfur showers with fear in their voices. A fine yellow powder would settle on wells, on wooden fences, on the backs of grazing sheep. Villagers whispered about brimstone and warnings from the heavens. The powder smelled faintly bitter or sometimes sweet. and it clung to wet stone in soft golden streaks. Old church records from the Middle Ages carried careful notes about these events, often paired with prayers and drawings of small yellow clouds hanging over the fields. The modern explanation for most of these cases is elegant in its simplicity. Wind carries pollen. Pollen is light. Light things travel far. Conifer pollen in particular has small air sacs built into its shape, like tiny inflated wings. Those sacs give each grain a buoyancy that lets it drift on the slightest breeze. Under the right conditions, billions of grains can rise together on a warm-up draft, cross hundreds of miles, and then settle all at once when the air grows still. The math balances. The mystery, in most cases, dissolves. Yet not every yellow fall is pollen. This is where the numbers grow interesting again. Volcanic sulfur, blown high into the atmosphere by a distant eruption, can drift on the jet stream at speeds of 200 miles per hour. A single eruption can inject millions of tons of sulfur compounds into the upper air. Those compounds can circle the globe in weeks. When they finally settle, they may fall thousands of miles from their source, staining rain a pale lemon color and leaving faint yellow rings inside puddles. Desert dust follows a similar arithmetic. The Sahara alone releases about 180 million tons of dust into the atmosphere each year. Some of that dust reaches the Amazon, some reaches the Caribbean, some reaches the Alps and tints the snow a rusty gold. The particles are so small that gravity barely pulls on them. They float for days, sometimes weeks, held up by warm rising air and gentle horizontal winds. The numbers are staggering, and yet they follow the same quiet rules that govern a falling leaf. There is a certain beauty in how these systems balance themselves. A pollen grain is roughly 1,000 times heavier than the air around it, but its shape and surface area let it fall slowly at only a few centimeters per second. That means a grain lifted to a height of 1 kilometer might take 5 or 6 hours to settle back down. During that time, a steady wind of even 10 kilometers per hour can carry it 50 or 60 kilometers away. The arithmetic of small numbers multiplied across billions of grains and long stretches of time becomes the arithmetic of a sky-wide event. Still, not every yellow fall fits so neatly into these equations. Some historical reports describe powders that burned when touched, or gave off a sharp mineral smell unlike any pollen. Some samples, when finally examined under early microscopes, contained tiny crystalline shapes rather than the familiar rounded grains of plants. One theory holds that these rare events involved genuine volcanic ash carried on unusually strong high-altitude currents. Another suggests that industrial pollution, once it became common, contributed its own yellow tints to certain rains. A third view, still debated, is that some very old reports may have described events with no single cause, but rather several substances mixing together in the same storm. The elegance of the math does not always give us a final answer. It gives us a range of possibilities. It tells us what could travel that far, what could rise that high, what could fall in such quantities. It rules out some explanations and leaves others open. The numbers are honest about their limits. Somewhere tonight, in a quiet valley, a thin layer of yellow dust may be settling on a window ledge. The wind that carried it may have started its work 1,000 miles away, days earlier, in a forest or a desert or a mountain crater. The arithmetic that placed it there is silent, invisible, and old. And it continues, grain by grain, whether anyone is watching or not. Sailors have always kept the strangest records. For centuries, they lived under skies so open and vast that they saw things landsmen rarely noticed. Their logbooks, kept in careful ink on damp paper, hold some of the oldest accounts of odd things falling from above. A ship far out at sea has no shelter, no trees, no city walls to hide the weather. Whatever the sky drops, the deck receives. Old ship logs from the 18th and 19th centuries mention showers of small fish landing on the boards during sudden squalls. Sailors described tiny silver bodies flopping across the planks, far from any river or shore. Some captains wrote of jellyfish tangled in the rigging after a storm. Others noted red dust settling on white sails, staining them the color of rust. These entries were often brief and matter-of-fact. The men who wrote them were not chasing wonder. They were simply logging what happened, the way they logged the wind and the stars. The reason sailors saw so much may come down to one delicate truth. The ocean, the sky and the wind are woven together in a balance so fine that small changes can lift small creatures thousands of feet into the air. A waterspout forms only when the temperature, humidity, and wind shear line up just so. Shift any one of those things by a little, and the spout never forms. Shift them the other way, and it grows into something larger. The sailors who saw fish rain were witnesses to a system perched on a very narrow edge. That edge is part of what makes Earth so unusual. Our atmosphere is thin, only a few dozen miles of breathable air pressed against the surface. Above that, the gases grow so sparse that they can barely hold heat or moisture. Yet within that thin skin, water rises from the sea, gathers into clouds, freezes, falls, and rises again. The whole cycle depends on temperatures that stay within a narrow band. A little warmer, and the oceans would boil away over time. A little cooler, and the water would lock itself into ice. Sailors in the age of sail lived closer to this balance than most people ever have. They watched the barometer drop before a storm. They felt the wind shift on their cheeks. They noticed when the sea turned strange colors from blooms of tiny organisms drifting in the currents. Some of them recorded rains of soft flakes, like ash that dissolved in the palm. Others saw the sea itself glow at night with pale green fire, the light of countless small living things. The line between what came from the water and what came from the sky was not always clear to them. One old account from the Indian Ocean describes a shower of small crabs falling on the deck during a heavy rain. The crew gathered them in buckets and studied them by lamplight. Where they came from, no one could say. A waterspout may have lifted them from a shallow lagoon and carried them out to sea, releasing them miles from any shore. That is one theory. Another is that the crabs were swept up by a storm surge and tossed into the rigging by breaking waves. Both explanations rely on the same fragile balance of wind, water, and heat. The question that lingers is how often these events happen without anyone to see them. The ocean covers most of the planet, and much of it is empty of ships. A shower of fish could fall 100 miles from any witness and vanish back into the waves. A patch of red rain could stain the sea and dissolve before dawn. The sky may be busier with strange falls than we know. Only the presence of a watching eye turns an event into a record. Sailors gave us many of those records, quietly in the margins of their working lives. Their notes remind us how much of the world goes unobserved. They also remind us how thin the atmosphere really is, and how easily its rivers of air can carry small living things across enormous distances. A drop in temperature here, a shift in pressure there, and the invisible machinery of the sky produces something no one expects. Whether every strange fall recorded at sea can be explained by ordinary weather remains an open question. Some fit the waterspout theory cleanly, others do not, and the samples were long ago lost to salt and time. What the old logs offer is not proof but testimony, a long, quiet chorus of men saying, yes, the sky can do this, we saw it happen, we wrote it down, and that testimony still waits in dusty archives for someone to read it again with new eyes. On certain quiet winter mornings, in places that seem ordinary in every other way, people have stepped outside to find birds lying still upon the ground. Not one or two, but sometimes hundreds, small dark shapes, scattered across lawns, rooftops, and empty roads, as if the sky itself had let go of them all at once. It is one of the strangest and saddest of the sky's mysteries, and it remains, in many important ways, unsolved. The birds that fall in these events are usually small songbirds, often blackbirds or starlings, sometimes grackles or finches. They travel together in enormous flocks, moving as one shifting cloud across the winter dusk, and then, without warning, the cloud comes apart. The birds tumble in silence to the fields below, the streets below, the frozen yards below. By morning, the ground is strange with them, and the town wakes to a question no one can quite answer. Scientists have gathered many of these birds over the years and looked carefully at their small bodies. In some cases, they have found signs of blunt injury, as if the flock had struck something in the dark. This has led to one leading theory: a loud sound in the night, perhaps a distant firework, perhaps a sudden crack of thunder, perhaps a low aircraft, may startle the sleeping birds into panicked flight. In the darkness, they cannot see well. They collide with trees, with wires, with each other, and with the hard ground. The theory fits some of the evidence. It does not fit all of it. Other researchers wonder whether weather plays a quiet role. A sudden cold pocket in the upper air, or a hailstorm passing through a flock at altitude, could knock birds from flight in numbers. Ice on their small wings could make flying impossible. In a few cases, the birds have been found with traces of ice or with lungs that suggest a rapid change in air pressure. But in other cases, no such traces appear, and the mystery deepens rather than shrinks. There is also the question of illness. Diseases move through flocks the way whispers move through a crowd. A weakened bird may fall from the sky simply because its body can no longer hold the air. When large numbers of birds die at once, disease is often examined first. Yet in many of the strangest falls, the birds have appeared healthy in every measurable way. Their feathers are bright, their bodies are strong. Whatever took them from the sky left almost no trace behind. Some scientists have wondered about the role of the bird's own sense of direction. Songbirds navigate using the Earth's soft magnetic field, and using the stars, and using shapes on the ground far below. On rare nights, all three cues may fail at once. A cloudy sky hides the stars. A magnetic disturbance from deep in the planet blurs the internal compass. A blanket of new snow erases the familiar landmarks. In such moments, a flock may simply lose the sky. Whether this alone could cause a mass fall remains an open question. The events are rare, which makes them hard to study. By the time researchers arrive, the ground has often been cleared, the weather has moved on, and the small bodies tell only part of the story. There are no cameras in the upper air where the fall began. There are no witnesses, only the aftermath. The moment of the event, the seconds when the flock came apart, lives entirely in the dark space between what happened and what can be measured. Folklore has long held that such falls carry meaning, a warning, an omen, a sign of some deeper turning. Communities have gathered in quiet worry, wondering what the sky was telling them. Science has offered gentler answers, and probably truer ones, but even science has not gathered all the pieces. The birds fell, the sky did something, and the exact something has more than one possible shape. What we do know is that the sky is not empty at night. It is full of small travelers, moving in vast, quiet flocks, guided by senses we are still learning to understand. When they fall, they remind us how thin the line is between flight and ground, and how much of the world above our heads still passes without our notice. For tonight, the mystery can rest. The flocks are moving somewhere in the winter dark, threading through cold air, following the pull of a planet whose signals shift in ways they cannot always read. Most nights they arrive. Some nights they do not. And the reasons gathered slowly over many decades still add up to something less than a full answer. There is a strange kind of fall that has puzzled walkers and farmers for hundreds of years. They call it star jelly. On quiet mornings, after a night of rain or a passing storm, someone crossing a field notices soft, clear blobs of jelly scattered across the grass. The blobs sit there like little pools of clouded glass. They are cool to the touch, faintly slippery, and often smaller than a person's palm. The name is very old. In parts of England and Wales and Scotland, people once believed the jelly fell from shooting stars when a bright streak crossed the night sky, and jelly appeared in the fields the next morning. The connection felt obvious. Country writers from the 1300s and 1400s mention this belief. Even the word for it in some old languages means, roughly, star slime or star rot. The mystery has never fully closed. Scientists have studied star jelly many times in many countries, and the results are strange. Some samples turn out to be a kind of blue-green algae called nostoc, which swells up into clear jelly when it soaks in rainwater. Other samples appear to be the remains of frog or toad spawn, dropped by birds that could not finish their meal. A few samples have been identified as a slime mold, one of those odd living things that is neither plant, nor animal, nor fungus. But not every sample fits neatly into these boxes. Some collected blobs contain no DNA that any lab can identify. Others break down so quickly, within a few hours of being found, that there is nothing left to study by the time a scientist arrives. That is the deepest part of the puzzle. The jelly seems designed almost to disappear before it can be understood. One theory holds that all star jelly has a plain earthly source, and the mystery only lasts because the material rots so fast. Another view suggests there may be more than one kind of star jelly, and we are lumping several different things under a single old folk name. A third possibility, quieter and more curious, is that some rare falls really do involve material carried down by air currents from far away. Pollen clumps, algal mats, or biological debris lifted by storms and dropped in soft, wet blobs. Now think about what will happen to this small, gentle mystery across the long, slow time still ahead of our planet. In 1,000 years, our tools will be sharper. A scientist may walk into a field with a small handheld device, press it to a blob of jelly, and read its full genetic story in seconds. Perhaps by then every kind of star jelly will have a name and a source. The old country belief will live only in poems. In 100,000 years, the fields themselves will look different. Ice sheets grow and shrink on long cycles. Forests move north and south with the climate. The meadows where jelly is found today may be tundra, or ocean floor, or dry steppe. New species will fill the ponds and the soils. New forms of algae, new slime molds, new spawning creatures may leave behind entirely new kinds of soft, clear blobs in the morning grass. In 1,000,000 years, humans may or may not still be here, and if we are, we may barely resemble the people writing and listening tonight. But the physical process that seems to make star jelly, small living things swelling with water, soft tissue left behind by predators, storms carrying biology into the sky and setting it down again, that process will still be running. The sky and the soil will keep exchanging quiet gifts. In 1,000,000,000 years, the sun will burn a little hotter. The oceans will slowly boil away. Long before then, the biosphere we know will have changed beyond recognition. And yet, in whatever damp corners remain, some living thing will still be swelling in the dew. Some storm will still be lifting particles into the clouds. The pattern of strange soft things appearing on the ground after rain is not tied to any one species. It is tied to water and life and weather. As long as those three exist together on this world, small mysteries will keep landing in the grass. That is a comforting thought to fall asleep with. The specific puzzle of star jelly may be solved in your lifetime, or in your grandchild's, or never. But the deeper habit of the earth, dropping soft, unexplained things into quiet fields at dawn, is much older than any of our questions and will outlast our answers. The sky has always been a slow, patient storyteller. It shares its tales in fragments, in blobs of jelly and drifts of colored dust, and asks us very gently to keep wondering. For most of human history, when strange things fell from the sky, people had only their eyes and their stories. A villager saw fish flopping in the mud. A farmer found red stains on white sheets left out to dry. A shepherd picked up a curious lump of jelly in a meadow at dawn. The evidence washed away, or dried up, or was carried off by dogs and birds before anyone with a curious mind could examine it. The mystery was preserved only in memory, and memory softens the edges of every strange thing it holds. Today, the tools are different. Rain gauges sit in quiet backyards, ticking softly through the night. Weather radar sweeps the sky in slow green arcs, watching the shape of every storm. Satellites drift overhead in silent orbits, taking pictures of dust plumes rising off distant deserts and tracing them across whole oceans. In laboratories, scientists can take a single drop of red rain and count the cells inside it, read the chemistry of each grain, and compare the DNA of anything living against a library of known life. The sky is being watched more closely now than at any time in our history. And still, the falls remain strange. When red rain returned to parts of Kerala and Sri Lanka in later years, samples were collected in clean glass jars within hours. The cells were photographed under electron microscopes. Their walls were measured. Their contents were tested. Yet even with all of this careful looking, the debate did not close. Some studies pointed clearly toward a certain kind of airborne algae. Other studies raised questions. The algae idea could not fully answer. The instruments gave better data, but they did not give a final answer. The story is much the same for star jelly. Modern researchers have gathered fresh samples, sealed them in cold containers, and carried them to labs the same day. Some samples turn out to be the remains of frogs. Some are slime molds. Some are cyanobacteria that swell in water. And some, still, refuse to match anything on the shelves. The mystery has not vanished under the microscope. It has simply grown more precise. Perhaps this is the deepest lesson of the strange falls. Better tools do not always solve old questions. Sometimes they only sharpen the shape of what we do not yet know. Step back for a moment. Picture the whole earth from far above. A soft blue sphere wrapped in a thin skin of air. That skin is only a few miles thick, thinner than the peel on an apple, and yet inside it, every day, water rises invisibly from oceans, dust lifts from deserts, spores drift up from forests, and tiny living things ride the winds across whole continents. The atmosphere is a slow river of life and matter, always moving, always mixing. What falls from it is only the small part we happen to see. The atoms in that river are older than the earth itself. The calcium in a falling hailstone, the iron in a red raindrop, the carbon in a small fish tumbling from a waterspout, all of these were forged long ago inside stars that lived and died before our sun was born. When those old stars ended, they scattered their atoms into cold clouds of gas. Those clouds slowly gathered into new suns and new worlds. Our planet formed from that dust, our oceans, our bones, our breath, all built from the same ancient material. So when a strange substance falls from the sky and lands quietly on a field, it is, in a small way, a meeting of very old things, star-born atoms, gathered into water, lifted by sunlight, shaped by wind, and returned to the ground. The mystery of what it is joins the deeper mystery of where all of it came from in the first place. The instruments will keep improving. New satellites will map dust plumes with finer detail. New sensors will sniff the chemistry of clouds. Someday, a swarm of small flying machines may follow a waterspout from start to finish and record everything it lifts and drops. Some of the old puzzles will surely be solved. New puzzles will surely appear. The sky has been generous with its strangeness for thousands of years, and there is little reason to think it will suddenly stop. For tonight, though, the tools can rest. The satellites turn quietly overhead. The rain gauges wait in the grass. The samples sit in their labeled jars, still holding their secrets. And you can lie here in the soft dark, part of the same slow river, made of the same old atoms, wandering along with everyone who has ever looked up and asked what the sky just gave them. And so we come to the quiet end of our long walk through the strange things that fall from the sky. We have wandered through red rain in Kerala and fish tumbling onto dry fields. We have paused beside frozen boulders of ice and yellow dust that once frightened whole villages. We have listened to old sailors, old scribes, and modern scientists, each of them holding up their small lantern against the same soft mystery. None of it is fully solved. That is the truth. We can rest with tonight. The sky remains an unfinished story, still being written above our roofs and our forests and our sleeping cities. Think for a moment about how small each of these events really is. A brief rain of frogs in one village, a single afternoon of crimson water in one corner of India, a lone sheet of ice landing in one quiet field. And yet, across centuries, across continents, these small moments have gathered into a kind of soft worldwide chorus, a chorus that says, again and again, we do not know everything about the air above us. Some of these mysteries may be solved in our lifetime. Instruments grow finer each year, weather balloons rise higher, radar sees further. Careful researchers stand in the rain with clean glass jars, waiting for the next colored shower. Maybe one of them will catch the answer. Maybe a young student, not yet born, will look at old records and see a pattern the rest of us missed. Other mysteries may simply stay open. That is allowed. Not every question needs an answer tonight. Some questions are meant to be held gently, the way you might hold a smooth stone found on a beach, turning it slowly in your hand before setting it down again. Picture the earth, now, from a soft distance, a blue and white sphere, slowly turning in the dark oceans, catch the moonlight and shimmer like polished silver. Continents lie under drifting clouds. Storms move across them in slow spirals, gathering water, lifting dust, carrying small living things on invisible rivers of wind. Somewhere over a quiet coastline, a waterspout twists briefly across the sea and then fades. Somewhere over a desert, red sand lifts into the high air and begins a long journey no one will ever fully trace. The planet is doing what it has always done, breathing, circulating, moving warm air upward and cool air downward, carrying pollen from one forest to another, lifting tiny creatures into the clouds and setting them down now and then in places that surprise us. You are held by all of this. The same air that once carried fish over a startled village is the air moving softly against your window now. The same ocean that fed those old storms is still rising and falling on distant shores while you rest. The same slow turning of the earth that brought the sun up this morning will bring it up again tomorrow, gently, without hurry, without asking anything of you. There is something kind about a world that still has secrets. A world fully explained might feel a little smaller. A world with room for red rain and star jelly and unexplained ice keeps its mystery close, like a soft coat around your shoulders. You can sleep inside a world like this. You can trust it to keep its wonders safe until morning. Let your body settle now. Let your breathing slow. Feel the weight of the blanket. Feel the shape of the pillow. Somewhere far away, clouds are drifting across mountains you will never see. Somewhere, a quiet field is catching a light rain. Somewhere, a sailor is watching the horizon and wondering, as sailors have always wondered, what the sky might do next. You do not need to solve any of it tonight. You only need to rest. If some questions still turn softly in your mind, let them turn. Let the fish move gently through their strange upward journeys. Let the red dust drift across its long ocean crossings. Let the ice boulders stay unexplained a little longer. They have waited this long. They can wait one more night. The sky above your home is older than any story we have told about it. It has seen every strange fall, every colored rain, every quiet surprise, and still, most nights, it simply does what it is doing right now. It holds the stars, it holds the moon, it holds the slow breath of the planet, and it holds you too, resting beneath it, one small warm life among many, safe inside a world that is still, in the loveliest way, unfinished. Subscribe for a brand new Earth topic every night. One tap and something wonderful is waiting for you tomorrow. Sweet dreams.